I have cats. Why not? Thank you very much. Okay, so this is the IET's story of how we ended up building an AI, which is something we didn't quite set out to do maybe at the start, but it's been quite an interesting journey that we've been on. This is about how we rebuilt the production system for an abstracting and indexing database that we produce called InSpec. Before we do that, for those of you that don't know, the Institution for Engineering and Technology, we're one of the world's largest engineering institutions, a very precise number there that we're over, 168, I think we're actually about 170,000 now, in 150 countries, and we're very multidisciplinary as well. And our strapline and slogan is working to engineer a better world by inspiring, informing and influencing our members, engineers and the technicians and all those who are touched by or touch the work of engineers. So we cover an awful lot of things actually. Our primary areas are physics, computing, electrical engineering, but we cover aspects that spider off that in terms of anything that would touch around aspects of electrical engineering and construction, for example, and stuff like that. So it's quite a diverse set of material that we do. We cover astronomy and things like that. If you want to find out how to build a telescope, a big telescope, we've got stuff on that. If you want to find out how to power a nuclear submarine, we also have information on that. This is InSpec. Please don't ask me what InSpec stands for because I honestly don't know, and I'm not sure anybody in the organisation really does any longer. It is what it is. But it's a very, very highly curated abstracting and indexing database, as I say, covering engineering, computing and physics. We've been doing it for over 40 years. If you go to our website and find out about the history, they'll tell you they've been going for a lot longer than them. But from the point of view of becoming an electronically generated asset, about 40 years ago is when that work started. We have over 17 million abstracts, so much metadata. Wow. We really, I'll talk about that later on, actually, just to explain more about some of the stuff that we do in terms of the metadata that we apply. The other thing is we have, and it genuinely is, probably about 700 years worth of human expertise. We have people that have been there, man and boy, girl and woman, doing this work, and they care very, very greatly about the quality of the metadata that gets applied to the information. Really, really do care. And then we have various offshore expertise as well, and interestingly they also care really quite greatly about the quality of the work that they perform as well. And so we had this production system, and actually it actually really did look like that really did look like the systems diagram for the manual production system. It was very, very Heath Robinson. There were loops that went backwards and forwards and mysterious pathways and all kinds of bits and pieces, and it required an awful lot of humans in order to make it work. In fact, it looked a little bit like this. So we would grab customer XML, yay, customer PDFs, all right, customer hard copy, woo, and that would be the content acquisition process, and then we go through a content selection and indeed rejection process, and then we go to an integration process, and then we try and enrich it, and then we'd sit there. Seriously, we had an access database for delivery. That was a scary moment when we discovered that. We don't know what that did, but we turned it off one day and bad things happened. And as you can see from all the Lego figurines, clearly there's a competition going on today at SSP 2017. There were an awful lot of people involved. And we needed to change this. The technology was end of life. The manual methods were very restrictive and indeed expensive, but they were very, very high quality. And we'd reached a set of upper limits, coverage, volume, all of those things. There were clear opportunities to think about what we wanted to do and why. So if we were able to reboot the InSpec production process, we could open up new business avenues as well, if we got it right. The goals: deliver cost savings. Key point, actually, move the human effort further up the value chain. Who uses Apple Maps? Show of hands, Apple Maps? One or two. Who uses Google Maps? There you go. One's really rubbish, One's really very good. And the difference is humans. Even Google has realized that ground truthing those data sets is a really important thing if you're trying to get people from A to B at scale. And that's a philosophy that we have adopted here at the end of the day. Those are the rest of the things. The other thing, and again, 2 points, reconfiguring the data that we have in Inspect to allow new ways of asking questions, and also actually to build a new asset that we could then go and exploit further. A very simple version of what we've built. Oh, got a PowerPoint glitch there. That's the ingestion and normalization process to get to a standard point. The one I want you to pay attention to is the bit in the middle, actually, because that's where the AI that we've ended up building actually lives. And there's another thing that goes along with that, which is a knowledge graph that covers all of Inspect. And I'll talk a little bit more about that later on as well. Focusing on the AI. The key things are, what does it do? How does it work? And the really key question actually is it any good? All right. So ours reads text. It expects that text to contain engineering content and that content to be commensurate with the gamut of the coverage that we have within Inspec. It's actually looking for a specific type of text, the way we've set it up, in terms of what it does for the Inspec production that we do, but actually the system's designed to be a lot broader. It's quite text agnostic. So we've had some fun, for example, throwing large chunks of Wikipedia at it just to see what it can do with that, and it could do some very, very interesting things indeed. What it then does is it applies the full gamut of Inspec metadata and standards that we have around that metadata to the text. So we have uncontrolled indexing, which are interesting words that might be of use and value in the context of the material. We have controlled terms, we have classifications, we have numerical indexing. So we will translate any numbers that come in the text into SI units and make those SI units interoperable, basically, at the end of the day. We do a certain amount of chemical indexing. We are not a chemical database at the end of the day, but we do certain things about the properties of the chemicals, so semiconductors and stuff like that, those kinds of things. Astronomical objects, and a weird thing called treatment codes, which is basically, is this about theoretical work? Is it a practical application? What are the other ones, Cliff? Can you remember? I can't remember what the other... Experimental stuff, yeah. A huge set of complex and highly curated and highly managed concepts and relationships covering all of those areas. How does it work? As Christian said, we turned it on a few months ago, got rid of all the humans. I started to learn, and then it became self-aware, and we tried to turn it off, but it had already fished my credit card details, so it's live on Amazon Web Service. And a literary quote there for any of you who want to go look that one up. It keeps asking us who Wintermute is. No. It does this. So you've heard Christian talk about some of the tools. Actually, our AI uses a whole selection of the techniques and approaches. So heuristics, good old-fashioned rules, actually. Don't underestimate and don't dismiss good old-fashioned rules. You can do an awful lot with a good rule set. And after 40 years of curating this literature, we do have a very, very good rule set of things to go and look for and things not to look for and so on and so forth. It uses natural language processors to properly interrogate the text as if a human was reading it and make inferral from that. So it can pull out concepts like, is this talking about a person? Is this talking about an organization? When it doesn't absolutely know, because it can't find stuff in our data set of lookups at the end of the day. It uses a slew of statistical analysis tools and then a selection of AI algorithms. I'm going to talk about that in a moment, actually. A key point for us was around what we did. We built something called a domain model, which is a very structured representation. You might have heard this. Who's heard of the term domain model? Actually, a few of you. Okay, so it sounds like, nerd speak, but really, at its abstract level, it's a way of trying to represent systematically what your particular world is, and ours is the world of engineering, or that subset of engineering that we cover at the end of the day. business logic, if you've done business logic properly for your organization, you could think of that as a domain model in some aspects. So thinking about a domain model is an important thing if you're going to look at these kinds of activities, or you're going to be interrogating a vendor when they're talking about all the AIs that they've got, right? You could ask some pertinent questions around how they handle their understanding of your world, okay? And the other stuff, we built a proper formal ontology using all of that metadata. So we have inference and we have other things that you can do with that formal grammar that allows us to traverse the knowledge at the end of the day. And the machine has found that very helpful because ours is directed, so it has what it considers to be best in class to look up against as to what it should be doing at the end of the day. And it's been trained, directed learning, via a golden corpus that we called it. We basically took about 600,000 documents out of InSpec, and we selected those to say that those were the best of the best that we'd ever managed to do when we were doing our manual curation at the end of the day. So that represented, as far as we were concerned, the truth, right? We trained it on that. We looked at a few things. There's a machine learning methodology called AdaBoost. If you feel like some hardcore mathematics, knock yourselves out. Also another one called Word2Vec, which is different but similar. We also, and I thought I'd bring this up a little bit, we had a look at TensorFlow, and you may have heard TensorFlow mentioned. Go is based on, the Go machine is based on TensorFlow. We threw that at that data set that we got. It did some interesting things. It did some interesting things. And although we thought actually we might be able to get to a really interesting place, the fact was that we spent some time, frankly, going around in circles, and we sort of sat there and went, well, that might be a future, but it's not our immediate future at the end of the day. So actually we abandoned that approach. But it was interesting to see what it did to start off with. The important one, is it any good? The answer is yes, by the way, it is very good. But actually, it turns out to be really quite a hard question to answer, because when it gets good enough that you're not dismissing all the mistakes it makes and all the rest of those things, it starts to ask some fairly fundamental questions of what we had previously perceived actually to be quality. And I knew we were on something when we had 3 or 4 of our learned ladies and gentlemen with the many years experience actually sitting down there over lunch arguing with each other about whether they were right, or whether the machine was right. And there were people arguing on behalf of the machine. That's all right. We've also had to learn about, actually I'll move on a moment and come back to that. Here's some numbers. So anybody know what an F-score is? Okay, brilliant. So it's a statistical term, and it's a relationship between recall and precision. And here's some of the results that we've got. So this is for controlled terms. But the important point about here is when you're looking at this graph and these numbers with the percentages, so it skews over to the right. So in many cases, it's getting everything absolutely right, or with a very, very high percentage indeed. We're actually looking at the gamut of controlled terms that are applied to the document, not to the individual controlled terms. How often it's getting that right as it finds it within a text, but the fingerprint, if you like, for that given document, which is slightly different, an important measure that really, really mattered to us at the end of the day. On individual matching, it's extremely high. On the right-hand side, you'll see a excuse me, slightly different shape. These are our InSpec classifications, and they are meta-concepts. So in other words, it takes a look at what the document is, it takes a look at all the other metadata that's been applied to it, and says, on the basis of this, I believe that this paper, or the abstract of this paper, actually belongs in this area, and that area, but not that area, or that area. And that's a really complicated problem to get right. And I didn't think we'd be able to do it, and yet when you look at those numbers over there, it's actually doing a remarkably good job of that high-level understanding of what these things are all about at the end of the day. One of the key things is it's got us to a point where we've had to start really engaging now with how we think about quality across the entirety of InSpec. Previously, we looked at it on a per document basis because it was very manual and that's what we had to care about. But with a machine, what you have to understand is once this thing's starting to apply the way it thinks to the corpus of material that it's dealing with, when you start to make changes to that, some places may get better, but you have to watch out for other areas where all of a sudden it starts to get worse. So we have to look at a sort of population analysis of what we're doing with our InSpec processing at the end of the day. And candidly, that's the thing that we're working on at this moment in time. We went through 4 rounds of learning for this, and we could carry on doing that, but candidly, we won't fire that back up again until such times as we think we've got a robust process for making sure that we don't send the machine down the wrong path by not having a good understanding of our quality QA process at the end of the day. And it is very good. I've heard some of our more learned and cynical InSpec experts actually just say, well, that's perfect, which is quite something to say. And they're not shy about going, well, that's absolutely crap either. So to get them to say that, our estimation is that it is somewhere between a PhD level employee that we would bring in to learn about InSpec and then would train them for 2 years at the end of the day. So that's a really, really high level of expertise at the end of the day. We're never going to replace the human component. That's not our goal. Our goal is to move the people that look at this and work on this into that quality function, into that data checking at scale function, and into other areas where they can add further value to the data set that we end up getting. It is live. It is delivering us savings now. It's been running a couple of months now, and we're firing more and more stuff at it, and it's chewing through that quite happily. So that's quite a nice validation of the process that we've gone through at the end of the day. And the other thing is that it opens up this, and interestingly, of course, having looked at this representation of our knowledge graph, I'm sitting there going, change the colours a bit, and it really does look like HAL. We have a very large graph, a network now of all the relationships of all the concepts in our papers, and I don't have time to go into that in any detail, but we can do some very, very, very interesting analyses on that data set at the end of the day, and we are very keen to exploit that in terms of products, but also perhaps in terms of relationships we can have with publishers who we work with in the world of engineering at the end of the day. And that's us. Did you have any more? Christian's gonna. Sorry, you wanna? Yeah, it doesn't. Yeah. We've got a few minutes. I believe lunch starts at 12. It's 10:02 now. We've got a few minutes.
But so, it's all labelled lunch, so.
Is it? It's all. Yeah.
Just for the vegetarians.
If anybody's got any questions, anything they want to ask generally or whatever, a couple of questions. Go ahead. Probably use the microphone because I think we're being recorded.
Okay. Well, very interesting to hear the history and the current example. Any comments on the state of natural language processing and how that technology is? And obviously, if you're doing processing, publishing content, it's already been cleaned up manually. But is anybody doing natural language processing on uncleaned up content?
So our system will do natural language processing on stuff that's come out of Wikipedia, for example, and it does a very good job. There's an interesting point, right? Our stuff at the moment is set to pass InSpec levels of quality, right? Which is a thing that we care about in terms of the product that we offer. That's not necessarily a quality level that you actually want to apply in other cases. So again, this issue about quality and what it can do is an important one. I think there's been massive general strides made in the NLP stuff, to be honest with you. And another point that Christian mentioned, there are tools out there. Amazon's doing it in AWS. Microsoft are doing it with the Azure services. IBM are doing those kinds of things. There are a lot of tools out there that are actually abstracting away any of that problematic stuff. And so they're that good that they feel they can commoditize it to an extent that you can start to throw stuff to those systems and processes and just pay for the results back. And you wouldn't be doing that if the basics wasn't very good. Just to pull on the Google Translate, by the way, one of the kind of slightly mind-blowing things is that Google Translate now has its own language that only it understands in order to translate between different languages. So it's changed the way that technique works. It has its own syntax and its own grammar, and it built that itself, and even Google doesn't know exactly what it's doing. What they know is it could do a better job of going, I think, between English to Spanish to, I can't remember what the other one was, but doing those kind of cross language jumps at the end of the day. So there's really big strides being made. There's another question over there. Yeah.
Chomsky wouldn't like that.
No, Chomsky wouldn't like that, but he's an old man.
So I actually have two questions. So the first is, there's a lot of people that are starting to get into ontology. So the one that you created, was it a quasi-ontology? Was it using RDF triples? I mean, what did you actually use?
Yep, it's RDF triples. Some of it's quads, actually, for anybody who wants to get really nerdy. So we actually have different graphs that we've got up and running. We were lucky. We had the very good thesauri and the other controlled vocabularies to start with.
I love it, by the way. I'm a taxonomist
right.
and ontologist,
okay,
so
brilliant,
I've used
brilliant.
your stuff.
Yes,
Good.
so it is a true formal ontology with the formal grammar and the formal logic baked into it at the end of the day.
Okay.
People will say you don't have to do that. They are absolutely right when they say you don't have to do that. We did, because of the quality that we needed to achieve. So an important point about that is to get a feel for what's the problem you're really trying to solve, and therefore what are the tools that are appropriate for solving that particular problem. For us, going to the trouble of putting an ontology together was massively important and a key insight we had early doors. That's not necessarily true for everybody else. But also, don't be swayed by you don't need an ontology. You might. And you almost certainly, I would say, do need a domain model of some level in order to structure your business thinking.
And I had a second question, and that was, so I have worked on engineering auto-indexers and things of that sort using a golden corpus.
Yep.
The biggest problem that I see, that I also hear from vendors, is that they don't have enough people to actually create that golden corpus. So can you share how many people, how long it took? Some figures around that?
So we were very lucky because we had the data set. What we actually had was 40 years worth of QA data. So we were able to actually go back and pull out the specific best-in-class abstracts that we'd ever done across the piece and do that as an extraction at the end of the day. So that was very helpful to us. And of course, we had assets that allowed us to make sure that we were covering across the gamut of the areas that we're covering. If you go back to the slide I showed with the F-score curve, the ones that score low, it's really very simple. Even at 600K documents, we didn't have enough. Simple as that. And actually for us that's quite simple. We're not even bothering to solve that problem. Just send it straight through to manual. There's no point in trying to fix that.
Thanks.
Yeah. Anybody else? Okay, well, thank you very much, and hope you found it useful. Cheers.